I'm Anil Kumar, sharing with you some important topics which will help you prepare for pre-calculus. We will review functions. In introduction, we learned about domain and range. Domain is the set of all values of independent variable. Range is the set of all values of dependent variable in a function. Domain and range of transformed function is of our main concern in this particular video. We have already learned few basic functions and we'll see how domain range changes. So let me write down few examples that is going to help us understand this. So let me start with the square root function. It is the most restricted of all, and let me write this function as 5 minus x. Okay, so that is my function 5 minus x. We'll write domain and range of this function. So you can actually pause the video, answer the question, and then look into my suggestions. So that's one function which we'll consider. We can also consider a function which is like an exponential function. So let's consider exponential function. Let's say 2 to the power of x minus, let's say 3. So that becomes an exponential function which has been translated 3 units to the right. If I write minus here, it will be reflected on the x-axis. So let's do that part. This is positive, that is negative. Okay, so we'll consider these two functions and figure out their domain and range. Now the best way is to sketch these. Since we are interested in both domain and range, so we could actually sketch these functions. You can actually pause the video, sketch, and then check with my answer. So if I sketch original function as square root function, which is kind of like this. So let me just sketch an original function here, which is square root of x. Let's say this is square root of x, just to give you an idea. And it's also a good idea to rewrite this function in this form. If I take minus common, right? Minus common, I could write this as x minus 5. Now this is very important, since now it tells you clearly that your function is reflected horizontally on y-axis and is translated 5 units to the right. And therefore, the resultant is kind of like this. Do you see that? So here we have 5. One way to check is also, you could say that the inside part, 5 minus x, should be positive, right? Non-negative, I should say, and solve for that. So you could also do this. You could do 5 minus x should be greater than equal to 0, or say 5 is greater than equal to x, or you can say x is less than equal to 5. It makes sense, right? So it fits well. So that is a domain, but from the diagram we can see the range also, and we can write clearly that for the domain of this function is x belongs to real numbers where x is less than equal to 5. As far as the range is concerned, y belongs to real numbers where y is greater than equal to 0. So that is how you could do domain and range of this transformed function. Perfect. Let's look into this. Now the exponential function we're talking about, 2 to the power of x, is your parent function, which is kind of like this. This is 2 to the power of x. Now we'll consider the transformations. Reflection, that means y-axis, it goes down, and that is translation 3 units right. So at times you can also write your transformation. So it is the reflection on x-axis, so I'm writing in short, and that one is 3 units right. Right, so basically this function has been reflected and move 3 units right. Now this point is always 1. So when we say move 3 units right, we actually move this point to 3 units. This is critical. Now when it gets reflected, it will come here. So this is your minus 1. Do you understand what I'm trying to say? So that is critical. So this point moves here. So my graph actually will be kind of like this. So this point which we are tracking is 0, 1. It moves to 3, 1. Do you see that? So this point coordinates here are 3 minus 1, since it got reflected. Do you see that? So if I substitute 3 here, then I get 3 minus 3 as 0. Anything to the power of 0 is 1, and that is negative 1. It works. Perfect. So you could see what g of 3 is. So if you calculate this value, you get minus 1. That's the point which we covered, right? Anyway, to sketch a beautiful graph, you could plot some more values. But that gives you the idea and key to answer this question. You should not do more than this when you want to know only the domain and range. Okay, so the domain here is d of x. We could write this in interval notation. It's always, in this case, as you know, from minus infinity to plus infinity, right? So I just changed the notation, and range in this case is always less than 0, so it is from negative infinity to 0. Okay, where 0 is not included. So that becomes the domain and range of this particular function. Perfect. So with this, we have taken up 2 examples. I thought I have space. I will include one more example, and let's take up absolute function in this case. Now, the thing here is that what really happens if I put absolute function in the denominator. Okay, so I want to put like this, absolute function, and I want to put x on the top. So I'm taking linear function and absolute function, but kind of like this. So that's the combination I have taken. Can you sketch the graph of this and find domain and range? As far as the answer of domain range goes, we know domain cannot be x equals to 0, that's clear. But if you really sketch this, it will be very clear to find the domain range. Otherwise, you may get wrong result. Now to sketch this, we'll get back to absolute function definition. Absolute x is equals to minus, I should write first x. When x is greater than or equal to 0, we normally write plus first. So however, we are considering greater than first. Okay, so x less than 0, it is negative. That is how the function is defined. So you could write this as a piecewise function. So that gives me a good idea. Piecewise function. So we'll rewrite this function. H of x will be equal to 2 pieces. So it will be equals to x over x, which is 1, you see, when x is greater than or equal to 0, but it is equals to x over minus x, which is minus 1 when x is less than 0. You get an idea, right? So that gives you the function. In short, it will be looking like this. Minus 1 on this side, 1 on this side. Since we have included here, we'll fill this up. Do you get the idea? So that becomes your absolute function combination, where it could be numerator and denominator, giving you the same diagram. So from here, what is the domain and range of the function? Can you write it down? Okay, so we see that the domain of this function is indeed x belongs to real numbers, but as far as the range is concerned, what is that? So range of this function is y equals to either plus 1 or minus 1. Do you see that? So the range is restricted. It is plus or minus 1 for this particular function. I hope this video helps you to understand how to find domain and range of transformed functions. If you apply these strategies, you can actually find domain and range of all transformed functions. Now in the next video, I'll take combination of functions, which could be very complicated, but once you do that, you will be in a position to answer any question on domain and range. I'm Anil Kumar, and I hope that helps. If you like it, you can put the like, and always feel free to ask questions and share and subscribe my videos. Thank you and all the best.